The molecular shape is based off of V, S, E, P, and R. V stands for valence, S stands for shell, E for electron, P for pair, and R for repulsion. The shape of the molecule is determined by the electrons repelling against each other, and the electrons, they repel to get as far apart as possible. The electron's domain of a non-bonding electron pair repel more than the electron domains of a bonding electron pair. Multiple bonds are treated as a single bond because they have the same repelling force, and then the shape name is based on the location of the atoms.
Alright, this is a trigonal planar. It has 3 bonded pairs, and this is the construction of it. As I said before, the shape is a trigonal planar, and each bond angle is 120 degrees. It's called a trigonal planar because all the bonds are on the same plane and they form a triangle, triangle. And then it is not polar because all the bonds, they all meet at one place and they don't create any charges off of them. The shape is a bent molecular, and it has 2 bonded pairs right here and 1 lone pair up here. And the bond angle between these two are less than 120 degrees because they repel from the top pair of electrons. And this is obviously the construction of it. It's called a bent molecular because these two are bent. And then it is polar because these two meet right here, and then there's also a charge right here, and they do not equal out, so it's polar. This shape is a tetrahedral. It has 4 bonded pairs, and then the angle between all of these bonded electrons is 109.5. Obviously, this is the construction of it, and it is non-polar because these electrons make a negative here, and these make a negative here, and then the positives here, so they all come together. They don't have any specific charges on them or anything like that. And then it's called a tetrahedral because it has 4 electrons, and then they're all evenly spaced out. So.
Yeah.
Alright, this shape is a trigonal pyramid, and it has 3 bonded pairs, right here, here, and here, and then it has 1 lone pair. And the angle between these bonded pairs is less than 109.5 degrees, but we don't know for sure exactly what the angle measure is. And then it's called a trigonal pyramid because these 3 bonded pairs form a pyramid. And it is polar because the 3 bonded pairs, they meet in the middle right here, and then the positive part's right here, so they don't cancel out, so there's a slight charge on it.
Alright.
It says bent molecular. This is what it looks like. It has 2 bonded pairs, which are these 2, and 2 lone pairs, which are these 2. It's called bent molecular because the 2 that are bonded end up making a bend, like this. The angle measured between these are less than 109.5 degrees, and it is polar because the negative is right here between these 2, and the positive is here, so it's at different spots, which makes it slightly charged.
We're in action.
Okay, this one is the trigonal bipyramid. There's 5 bonded pairs, and this is what the diagram looks like. The angles between these ones are 90 degrees, so that's why there's a variation. These ones are 120 degrees. The reason it gets its name, trigonal bipyramid, is because it makes 3 triangles on one plane. So 1, 2, 3, and then 1, 2, 3. So there's 2 different pyramids. And then it is non-polar because all the electrons negative out here will end up being in the same spot as the positive mass. So it is non-polar.
Right. We're good.
Okay, this one is trigonal seesaw. This is what it looks like. There are 4 bonded pairs, which are these white ones, and 1 lone pair, which is the blue one. We cannot determine the bond angles between them. And then it gets its name seesaw because since this electron's gone or whatever, this ends up making a seesaw like this, and that's why they call it seesaw. It goes back and forth. And then
Good job.
it's polar because the electron negatives right here will end up forming right here, and the positives right here, so it has a slight charge to it. This is the trigonal T-shaped structure. This is what it looks like. There are 3 bonded pairs in the white ones and 2 lone pairs. It gets this T-shaped name because the bonded pairs end up forming a T like this, capital T. The angles between these ones are 90 degrees right here. And then there's a 180 degree bond angle between these two. And it is polar because the electrons, or the negative will be about right here and the positive is here, which will give off a slight charge.
Alright, this is the linear model. It has 2 bonded pairs, which are located right here and here. And then it has 3 lone pairs, which are the 3 blue ones shown right here. It's 180 degrees because the 2 bonded pairs form a 180 degree angle or straight line right in the middle. And it's nonpolar because the negative and positive ends meet in the middle of this diagram here. Right, we're good.
Okay, this one is trigonal seesaw. This is what it looks like. There are 4 bonded pairs, which are these white ones, and 1 lone pair, which is the blue one. We cannot determine the bond angles between them. And then it gets its name seesaw because since this electron's gone or whatever, this ends up making a seesaw like this, and that's why they call it seesaw. It goes back and forth. And then
Good job.
it's polar because the electron negatives right here will end up forming right here, and the positives right here, so it has a slight charge to it.
This is the square planar. It has 4 bonded pairs right here, these 4 white ones, and then 2 lone pairs, these 2 blue ones right here. It's called a square planar because each of the bonded pairs right here, each 4 of them, make a 90 degree angle between each. And it's nonpolar because all the 90 degree angles cancel out and they meet in the middle. So also meaning that the negative and positive charges also meet in the middle here. So that's why it's nonpolar. This is the octahedral. It has 6 bonded pairs, as you can see right here, all 6, and then there's 0 lone pairs. It gets its name octahedral because if you put a triangle between every bond pair, you can make 8 total triangles or 8 faces, and each bond pair has a 90 degree angle, and it's nonpolar because since all the angles are 90 degrees, they all meet up in the middle and cancel out. This is the square pyramidal. It has 5 bonded pairs, so these 5 white bonded pairs right here, and it also has 1 lone bonded pair, which is the red one right here. It has 90 degree angles and less than 90 degree angles. So the 90 degree angles will be right here as an example, and then a less than 90 degree angle will be right here. And there's less than 90 degree angles because of this 1 lone pair right here. It causes the 2 end bonded pairs, which I'm holding one of them right now, to repel from the lone pair. So that's going to cause this angle right here to be less than 90 degrees. And it gets its name because of the 4 bonded pairs, or the 5 bonded pairs. If you bring them up to the top, it'll create a pyramid due to the square base. And it's polar because the opposite bonded pairs come together to meet in the middle. But since there's 1 lone pair on the opposite side of this bonded pair right here, it's going to not even out and it's going to cause an uneven charge.